Hi guys, the goal of the portrait which I'm gonna present to you in a couple of seconds is to calculate safety stock in an easy way. My name is Sunny. Because of limited resource on internet, I'm painting the information to provide a managerial perspective to you. So, okay. So this is our inventory variability with respect to time. For the calculation of safety stock, you need to have the picture in mind, which is the demand of the safe of the whole inventory during the lead time. So I want to crop this picture and show you in a more detailed manner. So over here, as you can see, the mean of the lead time over here, and I have assumed this demand to be constantly decreasing in a downward slope. So this is the mean demand during the lead time, and this part over here will be our safety stock. So for the safety stock calculation, we need to use this formula, which is standard error of the demand during the lead time and the z value. So how to calculate the z value? You have to reverse engineer it. So this is the loss function over here. So whatever loss function you get from this formula, just you match it in the loss table, which is also known as LZ table, and the z value which will correspond to this LZ function will be your z value. So over here, the components of the equation is Q, F, and standard error. So Q over here was given, that was 10,000. F is the fill rate, which is the amount of customer you want to fulfill, like 96% or 98%. And this is standard error for our lead time demand. So how to calculate it? You go back over here. It is written as square root of 4 multiplied by 300. So where we got that? So this is the standard deviation of the demand of a week. So we need to multiply it because this is a sample standard deviation. We want to calculate this for the population, which is for the 4 week. So we need to just multiply it by root n, whatever the standard deviation of the whole population of whole sample is. Multiply it with root n and you will get the standard deviation of the whole population. And mu is nothing but lead time multiplied by the demand, which is the mean of the demand. So over here, just fill in the formulas and get the result. And this mu, which we calculated, is for the calculation of reorder point, which is nothing but safety stock plus mean of the demand during the lead time. So this is for when the demand is predetermined. If lead time is random, then you need to calculate using this formula the standard error during the lead time, which is nothing but sigma square equals to mu of L1, which is some other lead time, multiplied by sigma of the demand, which will be constant, I guess, and then sigma square of the other lead time multiplied by mu d square, and then take the square root. Sorry, oops, excuse me. This should be mu square over here. So I'll show you one of the real live example where I calculated it. So this is the Atlanta class case which I did. Over here the safety stock I calculated. For this I need to have z value multiplied by standard error, so we'll back reverse engineer it. So for the z value I need to have LZ value, which I got from the equation Q1 minus F equals to LZ multiplied with, over here you can see I'm using this equation. So Q1 minus F factor, it should be equal to LZ multiplied by standard error. So LZ is nothing but this factor Q1 minus F divided by the standard error. So you standardize it actually. So yep, that's it. Thank you. Thanks for watching this video and you have a great day. And special thanks to our Professor Gigi for teaching us so well. Thank you so much, guys.